Let's study about Bernoulli theorem. This is one of the most important topic of physics. This colors has been prepared by me with the help of Join for Education. The sum of energies possessed by the following liquid at any point is constant provided the flow is steady and non-turbulent. This is the statement of Bernoulli theorem. There is a pipeline. In this pipeline, let's see there are 2 points A1 and A2. Let's consider at A1 the cross section area of A1 is A1, a small A1, and pressure of the liquid at A1 is P1, and velocity of the liquid at A1 is V1. Hope that there is no problem to understand at this step. This is the surface of the earth, and this is the height from the surface of the earth, and this is the h1. Similarly, we consider at this point at A2 of the pipeline, then A2 is the cross section area at the point A2, and P2 is the pressure of the liquid at A2, and V2 is the velocity of the liquid at A2, and h2 is the height from the surface of the earth. Let's see the written statement of this one. So consider about an incompressible liquid in a pipeline. See in figure, the motion of the liquid is a streamline. Motion of the liquid is a streamline. At A1 liquid enter, and at A2 liquid leaves from the pipeline. Let the pressure of the liquid at the cross section A1 be P1. Already I have details about it, and A2 be P2. Let's consider about the work done at A1 and the work done at A2. So we know that pressure equal to force per unit area. It means that force by area. When F by A multiplied by cross section area A1, then we cancelled out A1, then we get here force, and this force is multiplied by velocity of the liquid. It means that displacement by time. Then we get here work done in this cross section joule per second. It means that uh, at A1 of the pipeline, work done will be P1, A1, V1. Similarly, at the point A2 of the pipeline, work done will be P2, A2, V2. Once again, I repeat here, uh, pressure equal to force per unit area. It means that F by A. So F by A multiplied by, this is the also area A2, and here will be V2. Then A2 or area cancelled out, then we get here A and V2 velocity. We know that displacement per second, so displacement by time, and we know that force into displacement equal to work done. So work done per second. So here at the point A1, work done per second will be P1, A1, V1, and work done per second at A2 will be P2, A2, B2. Let's see the written statement. So work done per second on the liquid entering A1. So here liquid enter at this point of the pipeline, and the value of this one will be P1, A1, V1. So hope that there is no problem to understand up to this step. So work done at A1 is W1, and already I have discussed about this or explained about this one. So force per unit area, so F by A into area into displacement by time, and we know that force into displacement equal to work done. So here work done will be per second. Similarly, work done per second by the liquid leaving at A2. So liquid leaves at this point of the pipeline, and this one will be P2, A2, B2. So suppose this work done at A2 is W2. So here will be P2, A2, B2. Hope that there is no problem to understand this one. So net work done on the liquid will be here W1 minus W2. So the value of W1 is P1, A1, B1, and P2, A2, B2. But see here, uh, volume of the liquid at A1 is equal to the volume of the liquid at A2, or volume of the liquid at A1 per second is equal to the volume of the liquid at A2 per second will be equal. So A1 V1 will be equal to A2 V2. Hope that there is no problem. So this one will be in this way. So work done equal to P1 minus P2. We take here A1 V1 common, or we put the value of uh, A1 V1 instead of A2 V2, and we take A1 V1 common, and the work done or net work done on the liquid will be P1 minus P2 into A1 into B1. Hope that there is no problem to understand the explanation of this one. If you have, write into the comment box. So this work done contributes change of gravitational and kinetic energy. So we find out what is the gravitational energy at A1 and what is the gravitational energy at A2 of the pipeline. So change in gravitational energy of the pipeline will be gravitational energy at the point A2 minus gravitational energy at the point A1. So we know that gravitational energy, it means that mgh. So we have A1, V1 and H1. So area multiplied by the velocity, then we get volume per second. Volume per second. When volume is multiplied by the density of the liquid, then we get the mass. So mass or mgh at A1. So the gravitational energy at A1 will be A1 V1 into density of the liquid into H1. Similarly, uh, potential or gravitational energy at the point A2 of the pipeline will be A2 B2 into density of the liquid into H2. So let's see the written statement which clear more. So this work done contributes for the change in kinetic energy and gravitational energy. So let's see. Change in gravitational energy already I have discussed here. See here. So change in gravitational energy, suppose this is the E1, or gravitational energy at the point A2 is A1 V1 and density of the liquid into G into H2. and gravitational energy at A1 is A1 V1 H1 and density of the liquid. So I have written here this one, and volume of the liquid at this point is equal to the volume of the liquid at this point. So A2 B2, A2 into B2 will be equal to the A1 into B1. So half that there is no problem to understand up to this step. So change in gravitational energy when the liquid moves from A1 to A2. Similarly, change in kinetic energy. Uh, Suppose change in kinetic energy is E2, and we know that kinetic energy equal to half mv square. So 1 by 2, and this one will be the volume, and this is the density. When volume multiplied by the density, then we get the mass, and this is the velocity of the liquid at the point A2 of the pipeline, and V1 is the velocity of the liquid at the point A1 of the pipeline. So here E2 or change in kinetic energy will be 1 by 2 A1 B1. So here A1 B1 will be equal to the A2 into B2. So volume of the liquid at the A1 already I have said so many times. A1 into V1 or volume of the liquid per second at A1 is equal to the volume of the liquid at A2 into V2. So change in kinetic energy E2 equal to 1 by 2 A1 V1, and this is the density of the liquid, and this is the velocity of the liquid at the point A2 of the pipeline, and this is the velocity of the liquid uh, at the point A1 of the pipeline. So this is the change in gravitational energy, and this is the change in kinetic energy. Sure. Work done will be E1 plus E2. So already we find out the work done W. So put the value of W and E1 and E2 here. So we get work done P1 minus P2 A1 into V1 equal to the value of A1 E1 is A1 V1 density of the liquid acceleration due to gravity, and H2 minus H1 plus 1 by 2 A1 into V1 density of the liquid V2 S square minus V1 S square. Of that there is no problem to understand this explanation. So if you have, write into the comment box, or attend online live class of Join for Education where I shall clear one by one or on a spot your any doubt or problems. So we find out uh, what is the relation of P or pressure and velocity and density and height at the point A1 and at the point A2 of the pipeline. Let's see. After the simple calculation, we get this one. So P1 plus or pressure of the liquid at the point A1, half density of the liquid, velocity a square of the velocity of the liquid at the point A1, density of the liquid acceleration due to gravity, and height uh, from the surface of the earth of the point A1. Similarly, at the point A2, pressure of the liquid plus half density of the liquid into velocity square of the velocity of the liquid and plus density of the liquid acceleration due to gravity and height from the surface of the earth. So pressure, density, velocity and height at the point A1 is equal to the at the point A2. So we write down here pressure of the liquid plus half density of the liquid into a square of the velocity of the liquid plus density of the liquid into acceleration due to gravity of the liquid and into height from the surface of the earth is constant at any point of the pipeline. So in this way, Bernoulli theorem is proved. Hope that this class will be useful to the schooling students having a subject physics as well as the audience who are interested in physics as well as competitive aspirants and GMAN and advanced and NEET aspirants. This class will be useful. Thank you very much to stay with me and hope that there is no any doubt to understand the statement of the Bernoulli theorem and proof of the Bernoulli theorem. If you have, write into the comment box. I will try my level best to clear your doubt or attend online live class of Join for Education to clear your any doubt on a spot.